Much of this has been pioneered by Steve Howe, who's a surgeon in California who I had a chance to visit to try to learn about this concept. I'll share some of those things that I've learned with you. So this is the world according to Steve Howe. So it's compared to a traditional total knee arthroplasty where we are desiring rectangular gaps in both flexion and extension. In his world, he wants an asymmetrical flexion gap, lateral side looser compared to the medial side in flexion. And that's critical goal of the procedure because the knee is looser laterally than medially. You want to resect, all bony resections are supposed to be the same. This is essentially the purest form of measured resection. And this is in contrast to our expected differences in bony resections, with the medial side typically resected more thicker compared to the lateral side. And in his mind, he doesn't necessarily care about radiographic alignment of his knees as long as he achieves symmetrical resections of all bony surfaces and these asymmetric flexion gap. So no ligament releases, restoration of this concept of offset, which I'll show you what we're talking about, and then again symmetrical medial lateral resections, assuming a normal cartilage thickness of 2 millimeters. So this is his distal femoral resection. So in contrast to setting your femoral guide at 5, 6, or 7 degrees of valgus, he sets his alignment at 0 degrees of valgus, assuming for wear in the, of up to 2 millimeters in the most worn parts. He has these bushings on the end of his jigs that he puts in there. And again, whereas we normally like to resect more off the medial side compared to the lateral side, his goal is to resect the same amount of the medial and lateral side, creating effectively a distal femoral valga compared to our normal distal resections. The rotation of the femur, again, is symmetrical on the posterior medial condyle compared to the posterior lateral condyle. This is in contrast to the more medial side that we typically resect in order to basically rotate the femoral component parallel to the transcanal axis. So in his mind, in his world, the femoral component in a kinematic aligned total knee arthroplasty should be relatively internally rotated compared to that of a mechanical total knee arthroplasty. So again, instead of 3 degrees of external rotation or 5 degrees, his rotation is set at 0, and you can see the pinholes there are relatively internally rotated in relation to the transcanal axis. The tibial component is also basically it's cut at varus relatively. In this system, he sets his tibial guide all the way lateral in order to achieve up to a 2 to 3 degree varus. This is something obviously very subjective, very difficult to control. He pays special emphasis to restore the slope and not increase the slope. He uses a cruciate retaining ligament, and in his failures, it has been resulting most of it from a lack of restoration of slope. So this is his quality control after each resection, symmetrical resections of both the medial and lateral sides of the distal femur and the posterior femur, and the tibia medial-sided and lateral-sided. What about the gaps? You can see that when he puts a laminar spreader, again, even with a cruciate retaining knee implant, the lateral gap's more open compared to the medial side. The ligament, the medial side is still relatively under tension, but the lateral side is clearly looser. He does go and still removes posterior ossifies when any. I mean, I think this technique works best in those knees with minimal deformity. The tibial is slightly internally rotated compared to what we normally teach or are accustomed to doing. His rotation is essentially set just medial to the tibial tubercle, rather at the junction of the middle medial thirds of the tibial tubercle. Again, in his philosophy, the tibia, the axis of rotation of the tibia, and the tracking of the tibia is best when the tibial tubercle is slightly internally rotated compared to the traditional mechanical axis. So this is after he puts in his implants, and this is what he looks for. He's essentially measuring the offset between the patellar tendon and his distal femoral articular surface with a knee at 90 degrees of flexion. And this is how he assesses ligament tension, or how he assesses his goal, how successful he will restore that anatomy. And you can see that his knee feels more lax than what we normally would accept when we use a PS or a CRD implant, but at least in this population, it works. He has published extensive work that he's done. He's done the most kinematic aligned total knees arthroplasty. This is a paper of 5 years of survivorship showing no catastrophic large number of early failures. He has since updated this with 10-year survivorship, Again, you can see in the short films, most tibia are varus compared to the traditional 0 mechanical axis. But even then, 98.4% at 10 years, which is not too shabby. But if you kind of pay attention to the long-standing hip-to-ankle knee radiographs, 73% still fell within the range of 0 plus or minus 3 degrees. And so, this are still very tightly governed alignment targets that we're not asking people to deviate from. Kinematic studies have shown that basically when you put a knee in a kinematic alignment, it leads to more normal contact pathways compared to the natural knee, but there's potential for edge loading, particularly if the deformities are too great. An early randomized trial showing that basically patients did similarly, but functionally patients did a little bit better when a kinematic total knee arthroplasty concept was applied. But some other studies that were a little bit higher quality, award-winning study like this one showed no difference in terms of Oxford knee scores, Flomax scores, and then most importantly, forgotten knee joint scores. We published an early meta-analysis on this subject showing comparable survivorship between kinematic and mechanical alignment, but kinematic alignment appeared to do slightly better early on knee society functional scores compared to mechanical axis. This is a most recent study published from Japan. The interesting thing about this was actually that restoration of the tibia vara, oblique joint line, was actually the only factor correlating with a patient that reported outcome scores that were superior compared to the other traditional measures, again suggesting potentially that restoring the patient's normal soft tissue identity may be important in how they feel about their knees. In terms of gait, there's some gait studies supporting that patients walk better with kinematic alignment, some that haven't found the difference, but also some that have basically shown that if you are too far off in terms of your alignment, patients do feel it and they are poorly functioning. At the end of the day, we don't necessarily know 100% what makes a good total knee, and alignment is only part of the equation. Things like laxity need to be figured out, and maybe potentially with things like alternative technologies like robotics, and more patients undergoing these procedures, we can quantify the data, we can derive better algorithms in the future to predict who belongs where and how lax should they be. So in summary, I think small deviations from conventional mechanical axis is safe. The concept of kinematic alignment merits further study, and refining the range of tolerances for long-term survivorships are needed. Thank you very much.
Gracias, Wu. Invito al doctor Juan Carlos Ordóñez a hablar sobre la elección en el diseño, ya sea móvil o fijo.
Hola, buenas tardes, gracias por la invitación. Mi tema es la decisión que lo toman en consultorio si eligen un implante de carga fija, o carga móvil. El reemplazo articular de rodilla tiene una tasa muy elevada y una recuperación funcional y una alta satisfacción por el paciente, y ha hecho que esta obtención de la función sea más fisiológica y prolongue la supervivencia de los implantes. Eso ha hecho que los cirujanos y también el alto índice de artrosis que hay en nuestro medio, cada vez haya más indicaciones de pacientes más jóvenes para reemplazo articular. Las prótesis de rodillas con platillos móviles se diseñaron originalmente pensando que el desplazamiento por debajo del inserto tibial iba a disminuir la fricción y por tanto el debris, y por lo tanto los implantes iban a durar más, pensando que los pacientes jóvenes iban a resultar beneficiados de este tipo de implantes. En ese sentido se diseñaron diferentes prótesis que se llaman el sistema de carga flexible o móvil. Este sistema supuestamente tiene una menor carga con referencia a lo que es platillos fijos. Los resultados, los estudios científicos no han demostrado ninguna diferencia, ni mayor revisiones, ni menor revisiones, ni aflojamientos el uno versus el otro. Lo que sí se vio al principio era subluxaciones del polietileno, derrames articulares a repetición, fracasos del componente tibial, que eran las complicaciones específicas de este nuevo diseño. Sin embargo, a pesar de que los diseños posteriores tuvieron muy buenos resultados clínicos, no se ha demostrado que estos implantes vayan a tener más ventajas que los implantes fijos que ya estamos usando. Hay puntos de vista contradictorios. Si los diseños móviles mejoran la función comparado con los diseños fijos, se dice en teoría que el paciente con un diseño móvil va a tener mejor rotación, más flexión, y eso va a permitir que tenga una función más fisiológica. En cierto grado sí, va a permitir que haga cosas que otro paciente no, pero va a tener también mayor desgaste y mayor carga. Lo cierto es que permite que haya una mayor congruencia, una mejor cinemática, mayor rango de flexión y como resultado final un aumento en la rotación axial. Este es básicamente el movimiento, el deslizamiento que haría el inserto tibial a la flexión máxima, y justamente hay diferentes estudios que comparan. Por ejemplo, este estudio comparó insertos tibiales fijos versus insertos tibiales móviles y realmente no hubo mayor diferencia significativa. Hay una discusión, hay una controversia con estos implantes que nacieron en el año 70 con el objetivo de reducir el desgaste del polietileno mediante la distribución de cargas y zonas de solicitación en las articulaciones femorotibial y femoropatelar, pensando que iba a reducir el aflojamiento, pero realmente no hay diferencia. Con estos dos objetivos, la idea de hacer esta doble superficie, cuya eficacia depende de los desplazamientos distales, realmente todavía no tiene evidencia, y entonces no habría razón para que nosotros indiquemos a un paciente nuestro uno de estos implantes, ya que si se afloja, vamos a ser responsables de por qué se aflojó el implante. Varios estudios avalan los resultados de la supervivencia a largo plazo de estos implantes con platillos móviles, con una tasa de revisión del 1%, y resultados similares obtenidos a los platillos fijos. Aquí tenemos una imagen, por ejemplo, de una luxación de un platillo móvil. Este es un estudio que mostró una incidencia baja, que esta sería tal vez la única ventaja, que hay una incidencia baja de liberación del retináculo lateral en los pacientes que se someten a un implante móvil versus un implante fijo. Sin embargo, los estudios a largo plazo son requeridos para tener los beneficios teóricos que tiene de menor desgaste y mayor durabilidad, que para eso es justamente lo que estamos indicando al paciente. Estas son imágenes de dos modelos de insertos móviles. Hay que recordar que los cirujanos muchas veces nos dejamos llevar por un dispositivo nuevo, que es el último modelo, pero debemos, como dijo Danilo, y como dijeron otros médicos aquí de renombre, debemos someternos a lo que ya nos ha dado resultado. Lo que nos ha dado resultado es el implante fijo.